All right, we begin our algebra quest here for real. This is the first real section on algebra here. That's not true. You've been doing algebra since first grade, but you didn't know it. We'll talk about that later, though. But anyway, this is the first pretty designated, lesson on algebra. Variables and expressions. Okay. A numerical expression is anything that has mathematical symbols in it. For example, a time symbol, or an addition symbol, or a subtraction symbol, or a division symbol. Those are called numerical expressions. Okay? A numerical expression would be 5 plus 8. That's a numerical expression. Another numerical expression would be 5 plus 8 divided by 3. That's one big numerical expression. You all understand that? There is a difference between an expression. I'll wait till you guys are all settled in. This is going to be new to you, and I would like you to be paying attention. There's a difference between an expression and an equation. An equation, what do you think an equation has that an expression does not? What do you think an equation has that an expression does not? Do you know? What? No. What does an equation? We don't talk about an equation for like 2 more days. I know. I think you might know. I'm waiting. What an equation. Equation. What do you think an equation has? An equal sign. This is an expression because there isn't an equal sign. If there was an equal sign there, then it would not be an expression anymore. It would be an equation, right? An equation has an equal sign where an expression does not. Okay? Anyway, a variable, which I'm sure you've seen before, I know you have. A variable is an unknown. It represents a number, but you don't know what the number is. A variable, the most common variable is x. I don't know why that is, but it is. It's the most common variable. Other variables can be n, m, y, anything, t, s. Why don't they do this? Why don't they have that? Why is S a pretty rare variable? Why is O a pretty rare variable? Why is L a pretty rare variable? Why do you think, Donovan? Because it what? Yeah, the S looks a whole lot like a 5. The O looks a whole lot like a... The L looks a whole lot like a... See what I'm saying? So you don't generally use those. You could. But it would be difficult for you as you're writing down your work on your paper to distinguish between a 0 and an O, and a 1 or an L, etc. So if you're going to use variables like that, you generally will do it in cursive. Because why is that? Why is X? You would think that X is a very poor example of a variable because the X could also be time symbol, right? That's why whenever you see me do an X as a variable, you'll always see me do it like that. What is that? That is a cursive X, right? So it does clearly look like an X. Also, you will learn very quickly here that you don't see this as times very much anymore. Very rarely do you see that as times. Times is not written with an X hardly at all once you get to algebra. I mean, very rare. Anyway, you know what else could be a variable? Any of those. A variable is simply a symbol to represent a number. It's whatever. I mean, the reason why I say you've been doing algebra since you were in first grade is because let me show you an algebra equation. Are you ready for an algebra equation? Do you think you might see that in first grade? Yeah. Guess what you would write it today? This is the exact same thing, except you would go 2 plus. That's coming. I'm going to give you that question at some point during the year. And my point is that you've been doing algebra since first grade. It's just that they used to use a blank or a box. And now we use a variable. It's the same thing. Nothing changes here. Does that make sense? You have been doing algebra since you were in first grade. You just didn't know it. Anyway, those are equations. Why are they equations? Because of the equal sign. We're dealing with expressions today. They ask us to use tiles and modeling. I don't use tiles and modeling. So let me explain though. This is what we're going to do today. It's pretty straightforward. All right? It's just going to be getting you in the habit of and getting you used to dealing with a variable and replacing the variable with what it's worth. I'm going to show you what I'm talking about. If I have this, first of all, what is that? Read me this. It's just 2x. That is 2x. What does 2x mean? Anytime two things are touching, when things are touching, it means multiply. The only time that's not true is if you have like a number like, 56. That's not 5 times 6. But I could go like this. 5 and then put it in a 6 in parentheses next to the 5. That does mean 5 times 6. Things that are pressed up next to each other means multiply. So this right here means 2 times x. You would say it, 2x. But it means 2 times x. Let's go around the room and just make sure we got this. Read me that. Read it to me, Michael. 5y. What does 5y mean? 5 times y. Exactly right. 5y means 5 times y. Okay? Jonathan, read that to me. Nope. Negative 2m. What does negative 2m mean? Not negative 2m times m, no. It means negative 2 times m. This, remember, they're touching. This is the number negative 2, and it's next to m, so it's negative 2 times m. Right? Okay. Read me that, Jenna. What does 15y mean? Okay. Read me that, please, Jared.
X minus 4.
Okay, that's not hard. Read me that, Sladen.
L over 4.
Read that to me better than that. Over. What does over mean?
Divided.
Divided by, right? That is divided by. That is L divided by 4. Make sense? Mama?
362p.
What does 362p mean?
362
Times p. Very good. We all think we have it? We all got that down? Okay. What if I have this? Read that to me, Emily. Read it to me. 3x plus 5. That's what that says. What does 3x plus 5 mean? It means 3 times x plus 5, right? Which one do I do first? If I had to do this in the right order, which one would I do first? 3 times x or the x plus 5? Sladen.
3 times x.
Because of the order of operations, right? Multiply and divide come before add and subtract. It's the rules of the order of operations don't change. What if I said this, that x for x equals 2? Here's the thing. This is the type of question you're going to see on your homework. It says for x equals 2. Let me tell you exactly what you do here. Okay, pay attention. This is something that you're going to have to deal with from now until you're dead, dealing with math. Okay? When you're replacing this, notice this. It says 3x plus 5 for x equals 2. It means that x does equal 2. You know that. It's telling you that. Okay? Since you know that, what you're going to do is you're going to replace the x with what it's worth. What is the x worth? What is the x equal to? 2. So you replace it. This is how you replace it. This is important. This is important. When you replace a variable with a number, you put it in parentheses. Instead of it going 3 times 2 like this, that's not how I want you to do it. You just simply replace it with parentheses. What is that number right here? May you read that to me? Read me that. What does it say? Joy, what does this say right here? What I just circled? What does that say? 3 times 2. That's exactly right. Remember, when two things are touching, it means times. That is 3 times 2, which it was 3x, and that also meant 3 times x. I replaced the x with a 2. Did I notice what I did? Did I put the 2 in parentheses? Yes, it's important that you do that. It may not seem important right now. Trust me, it will be. Plus 5. What is 3 times 2 plus 5? 3 times 2 is 6. 6 plus 5 is 11. The answer is 11. Does that make sense? Okay, you guys try one. Try and do one of these. You got to do it this way. You must replace it properly. 4 plus 2y. Y equals 8. So 4 plus 2 times 8. You had to put it in parentheses. If you forgot to put it in parentheses, then you really don't know how to do it yet. You've got to do that. And when you replace the variable with a number, you've just got to simply replace it. Just put it exactly the way it was, except you put the number in parentheses. Now, is this 6 times 8, which is 48? Did I do that correctly? No. How many of you got 48 as the answer? That is not the answer. What do I have to do first? Caleb?
Multiply 2 times 8.
2 times 8 first, right? 2 times 8 is 16. Oh, bring the rest down. 4 plus 16 is 20. Order of operations. How many of you got 20? Okay. Try another one. I'm going to do it anyway. Here we go. Replace it. 3 instead of m, I put in parentheses. Notice I just replaced the m with the number that it's equal to in parentheses. It's important. Plus 2. 3 times 80 is 240. Plus 2 is 242. There's our answer. How many of you got 242? Okay. I'm going to show you something else that you're going to have to get used to. Tables. A table will look like this. Some of them look like this. All right. I'm going to try to explain this. If I have this, in this column, if I have x, okay, and this is, and x is 20 here, what is going on in this column? What is happening in this column? X minus 3. So whatever x was, what's going to go in this column is minus 3. So in this column, since this over here is x, and it's 20, over here is x minus 3, which would be 20 minus 3, which is 17. Agreed? If that's true following that same pattern, what is, if this is 45, what belongs in here? 42. Right? And if this is 100, what belongs in here? Make sense? Does that make sense? Try one. Try doing... Fill in this column, right? You're filling in that one, you're filling in that one, and you're filling in that one. What number belongs in that top box right here? What number belongs here? If this is x, what is this column saying that we need to do? Add 6, right? So what goes here? 7. What goes here? What goes here? How many of you got 7, 10, and 13 here? 7, 10, and 13. Are you understanding, Caleb? Are you watching? Are you learning? Does that make sense now? Okay. Try this one then. I'm going to give you another one. Okay? What goes in here? Here's the deal. This is the x column. This is what's happening in this column. If this side over here is 0, what are we doing over here? Tell me what we're doing. Joy, what am I doing? Multiplying by 3, right? This would be 3 times 0. So the answer is 0, right? 3 times 0 is 0. What goes here? That is 6. What goes here?
15.
How many of you got those 3 right? 0, 6, and 15. You got it? I think you do too. Okay. Your homework, let me give it to you. Whenever they say to draw algebra tiles, you do not need to draw the algebra tiles. Just give the answer if that's possible. Just trust me. You don't need to use algebra tiles. If they say use algebra tiles to solve this, you just do it. You don't have to do it using algebra tiles. Just wait. Can you wait? Just wait. Can you? Awesome.